All right, should we start up again?
Yes, please.
All right. Anyway, so hopefully that's worked out for you. As I said, if it hasn't, then I'll certainly be around to help. Moving on, in the hands-on portion, you saw examples of kernel fragments and patches and how you would patch your kernel and whatnot. Um, Interestingly, the Linux kernel itself has had the ability to handle patches for a while. I don't know if it's been there from the start, but it's been there. Handling patches, the kernel config fragments, is not something that the Yocto project created, but I believe the Yocto project is one of the only projects out there that actually makes use of it and has tooling around that. Um, but it's very interesting, clever sort of thing. And what it allows you to do is it allows you to group configurations into basically features and BSPs and whatnot. Um, you might have a base configuration, and then you'll want to add uh, extra to it, and adding extra configuration to it might not only just need configuration changes, but it also might require patches as well. And so the Yocto project has a pretty nifty way of sort of grouping patches and config fragments together so that you can say, I want sound on this board, and you get sound and it handles any configuration changes and patches that are required for that. Uh, for the Yocto project kernel metadata, there are three types of metadata. There's SCC files, and there's the patches and the config fragments. You saw config fragments already. In my hands-on, I use DevTool because DevTool just makes it a lot easier for you. It knows that if you've changed the configuration, that you probably want the configuration fragment to go along with that. Uh, and there were people in the Slack who asked about this. Yes, you could just use bitbake, cmenu config, and cdiff config manually yourself. But DevTool kind of wraps all that together. It's kind of like doing a git pull instead of a fetch and an update separately. It kind of DevTool kind of puts it together. But DevTool, I'm using DevTool in the context of playing with the kernel. The dev tool was created for more than just that. You can upgrade recipes and do all sorts of, you can even, if you're playing with a recipe, there's even a way to push changes for that recipe to a device, and then so you can upload them to a device, and you can even uninstall them from the device and stuff like that. So DevTool is a much larger tool than what I've simply demonstrated here. And there will be a talk later by Paul Eggleton on DevTool, and so that should be pretty interesting. But I'm just using DevTool in a very constrained way here, just basically to play with the kernel config. Anyway, but config fragments should have a CFG extension because the tooling will look for that to know what to do with CFGs, for example. And then the patches, the other metadata, the patches, we also saw this in the hands-on. You generated a patch and DevTool did all that for you. And again, you could do it all manually, but DevTool just kind of takes care of a lot of the nitty-gritty kind of stuff for you. If you prefer to do it all yourself, that's fine. There's nothing wrong with that. I'm just demonstrating DevTool because I think DevTool is kind of neat. And also, like I said before, I mean, if you want to just generate an SDK and have your kernel sources off somewhere else and just use the SDK and do all this manually, you can create your own patches and stuff like that. But I think DevTools, and that's sort of the value add that the Yocto project is bringing to you. It's, you know, you're trying to build your device. You're not just trying to update recipes and stuff like that. So it's pretty nifty. Anyway, patches need a .patch extension. And then there's this new thing called the SEC. which according to the documentation stands for Series Configuration Control, although the documentation also says that this is a historic name, doesn't really mean anything. They're SCC files. And what they do is they tie together config fragments and patches to allow you to sort of group them together and say, here's a tweak, here's a thing I want to do. And these have an SCC extension. So as an example, I mean, let's say you are working with 6 different boards, and 2 of them have graphics capabilities and 3 of them have sound capabilities, but you know, only one of the ones with graphic capabilities also has sound. It's not as if graphics implies sound type of thing. One of them has as a raw NAND as its drive, you know, and 4 of them have DVD devices attached to them. And so there's like a mix and match of configurations here. By using the tooling, you can create a graphics SCC and a sound SCC and a this device has raw NAND flash SCC and this device has a DVD. And then when you're building for a certain board or a certain machine type, then you just simply include those. And now this board has, so they would all have a base configuration, for example. And then, but on top of that, you could add, you know, these 2 would have the graphics and these 3 would have the sound and stuff like that. So it's a way of organizing, because, you know, the simple way of doing that would be to create full def configs for all of your boards, all 6 boards. But if you realize that, oh, in the DVD kernel config, I forgot to add this or that, or I need to add this device or something like that, you would then have to go to all 6 and make sure that you fix them properly. Very error prone. Whereas if you had this all organized in SCC files, you would just simply fix the one SCC file, you would fix the kernel config fragment, and then respin your builds, and all your boards would have all the correct stuff that they need. So it's a pretty nifty feature. As another example, let's say you have development and production builds. On a development board, you might want to enable NFS, and maybe you don't need to enable all the security features of the kernel, for example, and you might want to, a lot of kernel modules, subsystems will have verbosity or debugging flags you can turn on. You might not want those in a production release, for example. You might want to enable hardening or random, you know, stack stuff and all that sort of stuff. So again, you could have flavors for development and production. You just simply enable them or not, depending on the build, and it keeps it all sort of neatly put together. Something we might also see is you might have a BSP layer for a set of boards, and they use different GPUs. And so getting a GPU to work, because it's so cutting edge, especially if you're using something like Panfrost or you know, Freedreno, where there's a lot of development happening, it might not be enough to just simply enable a config. You might need to also apply patches to get to sort of the latest, you know, DRM stuff, you know, working. So this helps you organize and keep all that kind of together. So now, where do you store these SCC files and these fragments and all this stuff? There's actually 2 places you can do it. You can do it in tree itself. You can do it in the BSP layer itself, but you can also do it as its own separate repository. You can have a repository. These are our build configs, and recipes can have multiple source URIs, and you just simply include it as a separate URI. Whether or not it is a local or as a separate, whether it's something you have to fetch over the network through Git or something, or whether it's a file within the local tree, you just simply specify it as a source URI. And in the, you know, when you specify a source URI at the end, there's the options. You know, there might be like a, you know, a branch option, or you know, no deep clone or whatever. You just simply specify the type option. You simply say type equals kmeta, And that's a flag to the Yocto tooling stuff that this is a chunk of metadata that's going to be used as for configuration stuff for SECs and config fragments and patches and whatnot. And it implies sort of a directory structure and a layout type thing. And but anyway, so as long as you specify that type, then you're all good to go. And then how do you include them in your build, your actual build? That's what the kernel features option is for. By specifying SCCs with kernel features, then it dictates which features get added where into which builds and to which images and whatnot. The whole kernel metadata stuff is actually a lot more complicated than this. There is a Yocto document, kernel development document that goes into much more detail. I didn't want to overwhelm. This could probably be a talk all on its own. I didn't want to overwhelm. There's all sorts of, you can specify types of kernels, such as the tinies and the dev and the RTs and stuff, and that can imply which configurations get applied. In fact, as part of your hands-on, when you do a core image minimal and you run it in QEMU, there's actually a QEMU, there's actually two QEMU specific SCCs that get applied. One of them is to enable the virtual, the pass-through file system type stuff. So you can have an image, core image minimal, but if you need to run it under QEMU, you would just simply apply those two SCCs and allows you to, and then the other one is a box DRM, BOCH, which is the DRM for the firmware, I guess, of QEMU. But anyway, so you apply those two, and now you have an image that can run under QEMU, as long as the QEMU machine supports that CPU type. But yeah, so it's quite convenient. Oh, and SCC files can include other SCC files. The SCC files have their own language. They have their own syntax, basically. And you can include other SCC files, but there's also a way that you can include an SCC file, but not anything that it includes. So you can stop the recursion. So it's quite twisty. But anyway, the manual has pretty good explanations on most of the stuff. I wanted to point out that it's pretty sophisticated, and there's a lot of ways that you can set these up, but I don't want to try and confuse it too much at this point. Anyway, if you want to look at examples of how to use SCC files and config fragments and kernel metadata in order to enable features and stuff like that, I would suggest looking at these various layers. I think Armin has done quite a neat job of integrating that sort of stuff into his Meta Odroid layer. And John Mason has done a lot of this stuff too with the MetaArm, specifically the MetaArm BSP sublayer of that repository. And then the Xilinx people as well have also put in a lot of SCC stuff. The Raspberry Pi BSP is also interesting because they're not using SCCs, but they are using config files, config fragments based on, for example, if you're enabling the 64-bit variant of the Raspberry Pi 4, then there's extra config options for the kernel and stuff like that. So their build actually checks for that. I'm going to just give me a second here. Where is, oh yeah, here we are. Share. Okay. Oops. So here, for example, is the Meta Odroid layer. And what I've done is I've just basically done a grep for SCC. Here, for example, at the top, we have an example of a machine conf file it's an include, it's a machine include file actually, where he's set this kernel extra features, kernel features or kernel extra features. And he's basically saying that, you know, by default, the Odroid should have the VFAT config fragment, you know, enabled. And then a lot of the rest of these are examples of SCC files, including SCC files. And these are all in the Linux, the Linux recipes, the kernel recipes subdirectory. And then the Linux stable recipe that he wrote, he's using sort of a source URI append here to add the Odroid SCC. So that's pretty interesting. Yeah, here's another example of the stable using kernel features for a specific machine. And so if Lima is enabled, which is a GPU, then he's going to enable this DRM SCC. So yeah, so it's a very well laid out example, meta arm BSP, and we can do that grep. Yeah. Yeah, so here again in the meta arm is, you know, SCCs that have been created for different machines and features that have been enabled. These are all in the kernel recipes, so as opposed to in the machine files. Let's look at the meta Raspberry Pi. Oops, sorry. Layers of layers. Oops. And there's no SCC files in here, but there are. Geez, but there are CFGs. So for example, we see, yeah, here's that Raspberry Pi 464 variant where they're including kernel Linux tree. Yeah, so here's the CFG files, the config fragments that they've created, and then they're applied in certain situations, power save, depending on, you know, sort of what build they're doing. Go back to the slides. Yeah. So that's pretty good. And then, of course, so those were all examples of having metadata in tree, in your BSP layer. Of course, it's not restricted to just BSP layers. So BSP is where it's used a lot, just for enabling features, period. It can be used for, but those were BSP examples. But anyway, so those were in tree. And for out of tree, there's the mega the mega repository, the Yocto kernel cache, which just has actually just has a lot of, I mean, it's huge. And this is a lot of the stuff, again, as I said, that Bruce Ashfield put together, which is just fantastic. Oh, I don't think I have it here on this machine. Oh, it's too bad. Anyway, it's huge. Anyway, check it out. It's yeah, it's got a lot of stuff, a lot of examples and stuff that you could probably use in your own projects. So anyway, so sort of wrapping up, recommendations. If you have to use a kernel, which you most likely do, I would strongly recommend using Linux Yocto if at all possible. If your SoC is supported upstream, then use Linux Yocto if you can. It's got a lot of features and a lot of stuff. Your users will appreciate being able to take advantage of all the tooling and extra features that come with that and the way that it integrates with the Yocto system itself. But even if you can't use Linux Yocto itself, like I said early on, if you're writing your own kernel recipe and you simply inherit kernel, you would need to do that. That's the base. Any kernel recipe would have to inherit from kernel. But if you also additionally require the recipes kernel, Linux, linuxyocto.inc, then that's where a lot of the magic that I've talked about today, that's where a lot of that comes in, and all the tooling and stuff that helps tie it all together. So if you can provide that as part of your kernel recipes, then you will be giving your users, you will make very happy users, providing your users with a lot of features and stuff that they'll find quite helpful. Anyway, that's it for today for this talk. If there are any questions, I'd be happy to take them. Thank you again to all the people who work on Open Embedded and the Yocto project, and great community, and everyone who's helped out in the Slack channel today, and all that stuff. And thank you to Lenaro for providing the Zoom, and the organizers and the other speakers. Oh, and also thank you for inviting me to talk. I very appreciate being able to talk. So thanks.